And then check all, uncheck all, invert checking, delete all check. That's the same ones that are up here in the image next to the image list where the X is. How do I know what I'm looking for? I lost an image, but I know it's in my image list. I don't want to have to click through everything. You can click on this image tab, and this will show you the images that you have. So if you're looking for a specific, say 0 to 1 view, you can click on this and it will give you a thumbnail tag of what's in that file or what that file is. And then when you're done, you can just unclick it and go back to just data. The other thing is if you double click the image, you can name it 36-inch weld 0 to 12. Now you have that data, 36-inch weld right here, and it also puts it above the image. Certain softwares, they put the information in the corners of the image. Rhythm, for instance, has the DICOM tags embedded into the corners. This is the exact same thing, but we do it all from the image property. So if we want to embed something in it, we put it up in the name. The next thing is the window and level. So you're going to hear a lot of contrast, brightness, window and level. It's the exact same thing. What that means is that when I hold the right click mouse down and I move the mouse up and down or left and right, I'm changing the brightness and the contrast. So smoothing, darkening, and you can see I can make it go light to dark, and that's just bringing in different contrast adjustments.
What is the 2768 and the 2328? Where does it get that reference?
Histogram.
Your data falls in between those, in between that grayscale value?
Correct.
Okay.
That's pulling out that saying that this image right now is when I save it. So and again, this is more along the lines of customers, clients, asset owners want to know what's the window and level of that image, because in the procedure, they may have something written in the procedure that says, for sure in aerospace, but in oil and gas, maybe not so much. But they'll say this can only be reviewed in this set of window and level data. We'll only allow it to be viewed at, since it's 16-bit, right? We'll only allow it to be viewed at 30% or 20% of the low end and 65-70% of the high end. So it has to be in that window, or it's too dark or it's too light.
When I look at this and I see a window level of that low, are customers comment about, well, wait a minute, that's not enough. That's not really enough penetration to qualify the data. Have you heard people say that?
Well, now you got to remember, this is not pixel, because look, if you look at my pixel on the left, so up here above image list at these coordinates, this is the pixel value. So wherever I put my mouse, that's giving you your pixel value. So your pixel value is absolutely spot on, 35,000 in the weld. The window and level that you're reading, that's different. Think about your brightness, your contrast. On your right-hand slide bars over here, if you adjust them, you see how it goes white really fast, or it goes dark, or washes out really fast. This is on the 50% basically of the dynamic range, 65,000 shades of gray. Pixel value, 65,000 pixels. 0 is undercooked or undershot. 65,000 is overshot. So just because this number, the window and level is 2432 by 2360, that's just your brightness and contrast. You got to remember bit depth, 16-bit bit depth, image monitors, 10-bit, 8-bit, 10-bit, 12-bit monitors. Its value is the visual brightness, not pixel value, but this is brightness. This is visual monitor brightness. We're not equating this to the actual pixel value, how much radiation went through. We're actually looking at this from an imaging viewing standpoint. So that's why that number here, for instance, this is a totally different shot. This is a little bit higher in the window and level, right? So this is up about 700 value. And look at how much lower the pixel value is. So the pixel value on this shot is 24,000. The pixel value on this one is almost 35,000, almost 36,000. And this has a lower window and level number. That's why they do this, is because when you're in the weeds, so to speak, or when you're undershooting your image, you need more window and leveling to get the desired image for interpretation. Does that make sense? Because a lot of customers will say, what does it look like in RAW? So that's RAW. You can see I turned off the filter. It's not such a bad shot. It's probably gradable. I don't see the IQ. Oh, there's the IQI. You would probably buy this because I can see everything raw. But look at this one. If I go in and put a filter on it, you can see how it smooths it out. Filtered, unfiltered. No filter on this because it's higher in pixel value, more radiation, maybe more films or more frames. You can see raw on the bottom, raw on the top, the pixel value and I'm looking at the weld. So where my mouse is, I'm over here on the top above image list on the left-hand side where I'm highlighting. It says at these coordinates, this is the pixel value. So we have 37,000. Raw, I can see the 2T. I can pretty much grade this without any filtering or actually a lot of keystrokes. So I don't have to do a lot of contrast adjustment. This one down here, I could still see it because I have a 3 megapixel monitor. It's not quite as clear, but you can see the pixel value is 12,000 difference. Not quite as sharp as the top image. When I'm talking about pixel value and I'm talking about window and level, they're totally two different things. The pixel, they do correlate in the aesthetic and the image, how it presents to you, but they're totally two different things because one is brightness, one is the contrast, one is the brightness, and the other one is how much radiation passed through the part to the detector. Whether it's CR, DR, doesn't matter. The pixel value is how much radiation is passing through so that you can get a good image. The first thing I do is I need to know what standard they're working to. ISO, ASME, API, whatever it is, what's their standard? So then we can kind of figure out what we have to do because there are some standards that have very strict guidelines. ISO, for instance, if the ISO requirement is Class A versus Class B, at Class A is less stringent than Class B, you have to have a 100 micron panel, let's say, for Class B. Class A, there's no requirement. Your signal to noise ratio has to be above 70, 99 for Class B or 70 for Class A. When somebody says to you, will this meet API 1104? Will this meet ASME Section 5, Appendix 9? Will this meet ISO? You need to know what the part is, what the thickness is. I can get with you and tell you, no, this won't qualify. 140 micron detector will not qualify for some thin Schedule 10, Schedule 20 piping. For 2-inch pipe, 2-inch thick or 1-inch thick pipe, double wall, absolutely, 140 micron will work. But on something like that Schedule 10, Schedule 20, even some Schedule 42-inch, we need to go to 100 micron to get the sensitivity that we need to see the defects that standard is calling out for. Unless it's a 75 micron panel, I don't think that there's one panel that can do everything. Unless it's like I said, unless it's under 100 micron or smaller. Maybe the one place you might have a problem is aerospace type, really thin, lightweight aluminums because the defect size, right? So when you get into that defect size that's smaller than a micron, just remember this: if your defect is smaller than a pixel, then we have to go to a smaller pixel. For oil and gas, I don't know of any pipe. I haven't run across any pipe yet that 100 micron did not work. Schedule 5. Schedule 5 is really going to be a 50 micron, probably 50 micron CMOS panel. Pixel value, again, intensity, it's where the mouse is. Brightness, contrast, or window and level, which is the WNL. That's just, again, it's just what we call lookup tables, LUT. So you see how it says LUT, and all I'm doing is I'm moving the mouse as I'm holding the right click, and it just gets brighter and darker, and it's changing that brightness, that contrast. If you're using gamma, there's a lot less of that contrast in there, so you're going to be on the lower end. But if you're using X-ray, like this is an X-ray, we're going to have a lot more window and level values to go through. So you can see when it's not filtered, you see how high that number is now. So now
Yes.
we're up in the higher. Yeah, that looks good with filters. How does it look without the filter? And that's because they want this window and level. They want it to be a true value, not a filtered level. So what this did was that filter stacked a bunch of different filters, sharpening, emboss, deconvolution, all these filters together to give a nice picture, but then you don't know what happened in the image, right? So you're not looking at raw image. You don't know exactly. We're not masking any indications. We're not removing any indications, but maybe you don't see undercut as well. You see some of these shadows by the numbers. That's because the filter is probably overdriven. This is raw data. And
Okay,
you can see, yep, you can see how it's not as smooth, and it's not driving to the peaks. It's kind of flattened out. Sometimes it's even more of a hill than a mountain. And then when we turn the filter back on, you see how it's nice and smooth. That's what filtering is doing. It's smoothing out the image to make it more appealing to the eye. Might be a little bit of enhancements for lights and darks, but it's definitely, again, raw. It's all sharp and jagged and rough. I'm still going to argue that there's nothing wrong with looking at an image filtered to do a grade. If the client wants to see it raw, save it in raw. But if you want to grade it as an interpreter, if you want to look at it, you should be looking at it in the best form possible so you don't miss a crack. If there was a crack by enhancing the filter, you just enhance that crack. You do not wash it out. You may do something which would be called, like, you induce an indication, because you may, if it's undershot or overshot, you may create a shadow on the toe of the weld, which may look like undercut.